Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about mega constellation in 2026. So let's dive deep into this. Well, here's deep. What does it mean to classify it as mega? Well, you have massive number of satellites doing one thing. Like all of them, like we have a lot of satellites, it's just that they are doing different things. Basically, we have a lot of LEO Earth observation satellite, we have a lot of medium Earth orbit navigational satellite, but they are all doing different things. Now imagine same number of satellites, like grand total, all of them are doing one thing. That's the requirement. And to give you a context of these numbers so you can understand like what we are talking about, GPS, it's a very successful constellation. 31 satellites active right now. They do have some spare, some hot spare and all that, but generally at any given moment in time, they will not exceed 50. 31 is active, more than good enough. Galileo, this is GPS of European Union, 33. GLONASS, this is Russian GPS, 24. Chinese also have their Baidu satellite system, and India also has their regional system, which is Navik. So grand total, you're looking at give or take 100 plus satellites maximum. If you count everything that is proposed for the future, you're looking at 150 satellites, and that's GNSS, as in like global satellite navigation system. So fundamentally, we are talking about satellites, and they don't need to be huge. Like for example, if you're for a TV broadcast, that was the big deal in 90s. Geostationary was utilized. Now here's the funny thing about that: you don't need a lot. Geostationary is like 36,000 kilometers away, meaning on paper only 3 satellites are needed, and it can do whole planet coverage, planet-wide coverage anywhere. And if you have like 6-7, you'll have enough signal strength to do obscuring, because again, if you have like only 120 degree apart, the edge angles will be like too much atmosphere, so signal will degrade. But if you have like 6, 12, you got this. Like you will cover everything, including poles. So you don't need that many satellites. However, the moment you are talking about something that is more than 1,000 satellites doing one task, more than 1,000 doing one task, and let that be clear, that 1,000 number is not law of physics or legislation law. It's a good number. So anything above 1,000, that's what we are talking about, mega constellation. And generally mega constellations can be packed into one orbit, but practically nobody does that. So even if you have like, okay, we have satellites in 300-kilometer orbit, most likely not all satellites would be 300 kilometers. Some would be 350, some would be 400 even. So you generally always spread out your shells. So for perfect coverage, for backup, for backhauling systems, you do need this sort of a wiggle room in your shells. You do not want all the shell to be as compact and tight as possible. So that is it. But generally, because geostationary is so expensive and so tight, you're not gonna do this sort of thing. Medium Earth orbit, while it does have high priority systems, because again, if Space Command has to make a decision between your satellite and GPS satellite, trust me, your satellite is gonna go kaput. So generally MEO, they want to be on lower end of the MEO, so they do not go too much. But LEO is the main place, because it has self-cleaning ability, meaning if you poop anything in there, it should, in optimum scenario, shift delete itself from there, as in like orbit, anything below 1,200 kilometer should shift delete itself. And if you are very low, like as low as like 400 kilometers, it should fall out of sky in give or take 2 years. So that does have the advantage that you can litter that place and forget about it, it will self-clean. So that is one expectation you have. So only few tasks will actually benefit from this sort of coverage. Let that be clear. It's not like, it sounds great to have thousands of satellites. It's not that practical. Like again, you can do whole planet TV coverage and like, broadcast coverage, few satellites only. You don't even need 50, like you good. India has a navigation system only with 7 satellites, and it takes care of, again, it's regional, but you can get the point. Like if you want navigational system planet-wide, 50 geostationary satellite, you're done, go home. So fundamentally speaking, you don't need that many satellites. So what are the field where you will have benefit of? First benefit, the main money maker, surveillance. Because you have to understand, satellite has to go from somewhere. If it's in low Earth orbit, it will go over very quickly. So benefit, you will get very high resolution photo. Penalty, it would be very fast and it will be very small window. It's like, whoosh. But here's the, imagine all the star tracker sensors that SpaceX have, all that black and white data directly feeding into the communication bus and feeding back to the ground. Now US Army will have the ability to see everything on Earth, and every satellite will be looking at it, because again, they have such a large number, there is coverage 100% of the time. So Surveillance, shut up, take money. Like as much satellite as you want to put, surveillance can eat it up. That's the first money maker part. Second, weather. Weather is a very high critical requirement, and weather is a noisy data set. You could have geostationary satellite that is looking at the whole planet, but it's not high resolution enough because it's very far. And again, atmosphere, density, chaos. So you do need high resolution data. For that, you need to come close. How close? As close as possible. So LEO can be utilized for a very high precision weather mapping. Communication. Communication not as a broadcast, communication as a two-way communication. There it makes sense, and all the mega constellation that right now is being targeted, they are for communication system itself. Now, be mindful, a lot of people had this idea long ago, but it was not viable because there was no SpaceX. There is a world before SpaceX and there is a world after SpaceX. So only after SpaceX, this idea of even opening your mouth and saying I'm going to launch 10,000 satellites becomes something digestible. So that's what we are talking about, mega constellation. So Starlink, again, every Tom, Dick and Harry knows about it. And be mindful, there were many companies before Starlink that tried to do something similar. Basically, what if you are in middle of oil rig and you just want to pick up your phone and it's like have a phone call. So satellite phone became a thing. And Iridium, Globestar, there were like 5-6 companies. Most of them either shut down or went bankrupt, including these two also. And if I'm not mistaken, after restructuring, Globestar has the dealing with Apple, if I'm not mistaken. That's who is the backbone of Apple emergency service system. Iridium, I do not even know who is the current owner. They have been sold so many times. So be mindful. People have tried it. It was not successful. Why it was not successful? Again, one company failing, it's like, okay, oops. Multiple company failing, what the hell? Simply because launch cost was stupid. Like they could not afford to launch a cheap satellite. They had to go YOLO like that, because again, if you want 99% uptime, that's cheap. You want 99.999% uptime, that's expensive. In satellite, because again, satellite launches were so expensive, they wanted that 99.69. Yeah, that 69 was painfully expensive. So, and not to mention, even if you made one satellite, you figured out how to make the second one. That would be cheap, right? Yeah, you can't, because if you made it, how will you launch it? There was no rocket. There was no scenario. It was like pick up the phone, one launch, pick up the phone again. Second launch was like, 1 week away. No, second launch was months or years ago, later, so to say. So stupid launch cost was the primary reason why all of this fall apart. And again, because of SpaceX, that is the only time where we can say this sort of thing, and it's logical that you can make economic return on it. So SpaceX are the only one. There are other companies that are trying, but as of now, that's the only SpaceX, and not even other nations combined, that can do it like SpaceX is doing it like it's a routine. For example, in 2025, they have bare minimum 3,000 satellites, Starlink satellite launch. And be mindful, this is not CubeSats. You can launch 100 CubeSat in one go. Even India did that. But those are very tiny CubeSat, very short lifespan. These puppies are actual workhorse, heavy puppies. So 3,000 of heavy puppies in decent orbit with ion thrusters, yeah, that's a big deal. And they did it in 113 launches. Be mindful that, to give you a context, there are 200 countries on this planet, give or take. To understand this deeper, there are only 10 nations that have space program. Put SpaceX on one side, everybody else on the other side. That's how asymmetric it is. Even China, with going all out, they barely match to SpaceX alone. So only SpaceX can claim and actually do this. Everyone else is like hoping for the best. So that is there. And recently SpaceX realized, because the SpaceX original model was they're going to launch their satellite, they're going to sell you the ground station, and you're going to use that ground station to connect with your stuff. While that does work, but somebody figured out, what if you can directly talk to this puppy? What if instead of satellite phone, those being big evil things that terrorists had is like, ta-da, hello, boom this place, or CIA agents, hello, boom this place. What if it was just your phone? You pull out your phone, sub, boom this place. So that required technology, different kind of algorithms, especially for the satellite end. So SpaceX bought a company known as SwarmTech. This allowed the technology for satellite to directly talk to these puppy. Now be mindful, SwarmTech was not designed for mobile talking, they were designed for IoT devices. They were dreaming a world where all the IoT device can have a backhaul connection with a satellite, because again, they did not needed high bandwidth or high throughput, they just needed connection. And for IoT devices, like let's just say you have forest measurement system, you want it in the forest, and again, it could be outside of communication range, but it will be always under satellite communication range. So that was the core foundation. SpaceX bought it, and SpaceX is expanding it. And if you ever wondered like how the heck Elon Musk got with T-Mobile, if I'm not mistaken, and it's like, okay, we're gonna allow directly sell a service. How the heck that can happen? Because of that swarm technology, that patents and all that. Now, be mindful that technology was designed for very low bandwidth, meaning WhatsApp messages, not even map navigation or anything like, just very minimal. It's almost like emergency SOS and WhatsApp message. And I'm being optimistic with that. So again, foundation is there, and SpaceX is claiming that in future they're gonna upgrade the swarm technology. Basically, we got the core idea and upgrade it so it can actually have data throughput. Not there yet. Although all that being said, the biggest advantage they have compared to any Tom, Dick and Harry else is that they have almost 10,000 satellite at the end of 2025. It's 9,300 or 9,400. Different people are giving me different number because again, satellites do die out. So. And again, by the time you're watching it, it's in February, so there is a good chance they might have touched this point, 10,000 satellite. Whole humanity, SpaceX, Starlink alone. Starlink has exponentially more, not a little bit more, exponentially more satellites. Meaning at this point in time, on any place on Earth, if you are doing a long exposure on wide angle lenses, you will see Starlink. Heck, I'm not joking, like once the winter comes down, I'll try photographing with this, astrophotography with this camera. I might actually see that. So it's a big deal. And again, how the heck they reached this point while everybody is just claiming? Rocket. Everything else was sorted. Like we got everything else. It's just that somebody had to be stupid enough to try this and succeed. He succeeded. Now this is a reality. I'm like, we are very close to reaching a point where there won't be any astronomy done on Earth simply because we just won't be able to see anything. So that's Starlink. Now, there is a competitor. Be mindful, this is the interesting part about open market. You might think, oh, there could not be any challenger to Starlink. There is. It's AST SpaceMobile. So the idea is, they did not have this idea of like, oh, I'm going to launch the satellite and then I'm going to sell you the ground station. The idea was, you have the ground station, this puppy. Now I'm like, okay, how can we do this now and we could not have done this in 1990? Well, we call it signal to noise ratio. This device can handle much higher signal to noise ratio compared to 1990s phone. That's on the mobile end, and same goes on the satellite end. Combine both of these two together, now you can have on the same wattage, tiny battery can do that with like, direct satellite communication. Oh, and be mindful, a lot of satellite communications for bit higher satellite, like 1000 kilometer, 1100 kilometer, those sort of ranges. Drop it down to 400 kilometers. You don't actually need that much power. So this company was directly firing missile on that. They were not like, okay, we're going to give data. No. Mobile network everywhere, the end. Directly focusing on that. So how can they achieve it? Well, they're not. They're just bouncing it. So this is not basically communication device. This is just a repeater. It absorbs all the radio signal, spits it back into the mobile ground station, and then collects all the data back and relays it back. It's just a repeater in space. It's a very clever implementation. They are not trying to be network in space. This does not have like laser. It could have, and I can easily see that in version 3 or version 4, they're like, okay, for the backhaul line, for this to repeat from the, certain points, it might have lasers. It might have like 3 lasers and communicating to, because again, you do have to spread them out. And you do want to make sure that that place is covered by cloud, this place will be active. You do want a routing ability. So that's the whole point. They might add it. Right now they haven't, but they might add it. And the another part is, let's just say you build a satellite. Let's just say you figured out you do not have to sell any ground station because everybody has the ground station. What is the next bottleneck? Spectrum. Here's the deal. Technology, super cheap. Any Tom, Dick and Harry can do it. Spectrum, yeah, you need lawyers with extra lawyers, with some more lawyers, and then some extra lawyers. Like, it is brutal. Companies do not go out of business because of like, technology complexity. They go out of business because it takes so goddamn long to get spectrum license. They used a cheat code because they are repeater, and they are not even trying to get all the market. They are like willingly, openly working with all other mobile companies. For example, in India, they are working with VI. India used to have a lot of mobile companies. One big daddy came up here, we call it Jio. It started to flood Indian market with super cheap 5G network. Only Airtel successfully pivoted quickly enough that they could stand in the market. All other kaputted. VI is Vodafone and Idea. There used to be 2 semi-scaled systems they had to combine to survive. And they are partnering with us. Now, here's the funny thing. VI still has licenses all the radio waves. And again, that's how AST is working with everybody. It's like, USA, I want a spectrum. Yeah, the end, don't waste your time. They go to Verizon. It's like, my man, I'm going to give you satellite network. You give me the spectrum license. And again, Verizon controls the spectrum, so they do not have to worry about competition or anything. It's like, hey, I have the license key. So that's how they are sorting the spectrum issue. They go to UK, Vodafone, my man, give me the spectrum license. Wherever they go, they use the mobile network company to bypass the spectrum issue. That's how they are bypassing it. Although it does come with that issue. This should not be able to provide internet in Iran because again, it does need to bounce back. In principle, it should be able to bounce back because Iran is not that huge. So you could have Iraq, Afghanistan, you could, bounce signal shallow enough, but unlikely. So they are bypassing the spectrum issue. And how much satellites they need for coverage? Yeah, here's the funny thing. They only need 150. It's like, how can you do that? This is the critical part. First, these satellites would be oversubscribed. Oversubscribed simply meaning if they have the ability to sustain, let's just say one customer, they will say they can sustain 10,000 customers. It's like, how? Why? That's how all mobile networks. If you ever had like 5G and you never got like more than hundreds of Mbps into this, that's the reason. On paper, it can do that if there was no other customer. Oversubscription, it's a normal thing. So they are doing the same thing. And the idea is every mobile tower, like customers, most of the time they will use terrestrial network, the networks that are already there. When they are out of range, like out of terrestrial, then they will bounce on that. So that use case, the uptime goes down drastically. So they can support it. And again, it's normal. Like we do that with mobile tower, doing that with space system, it's like no issue. And be mindful, if it can do even small data rate, which their testing suggests, they should be able to give 3 Mbps upload and 35 Mbps download inside, basically indoors, in planes. So that's more than good enough. And again, I do not expect you to get that, but it should be enough that you should be able to maintain your WhatsApp or your YouTube and all that. So that's more than good enough. And why only 150? These satellites are huge. They're not big, they're huge. Like huge, like stadium size kind of huge. And there is a very good chance we should be able to see this in a clear sky directly with naked eyes. Like these are huge. Like trust me, like when they are showing the small ones and it's like, it's big, and the big one, it's huge. So that's how they are doing it. It's a repeater in space, and their technology from day one was designed for this. They were not like, took out the technology for IoT device. No, they were very clever. They were not like, we're not going to sell ground station. We're not going to make too much stuff. We're just going to bounce it basically. And we're going to sell services. Benefit, they can sell services to multiple people without any issue. They're like, hey, we are going above America, Verizon, my man, have a discussion. They go above India. They're like, VI, my man. They go about UK, my man. Japan also, they have a contract. Oh, Saudi Arabia, they also have a contract. So that's the whole idea. They are not trying to reinvent the wheel. They're just clever about it. And the fact they are only with 150, they should be able to cover the whole planet. That's mind-boggling. Although let that be very clear, this does have size advantage. It's huge. Like to give you a context, hundreds of watt is the power output of all other satellites. This will be 20 kilowatts. Like it's a household solars are generally less than 10. This is huge. So, and be mindful, they not claims are free. Any Tom, Dick and Harry can make it. They got the demo done. In 2025, they had the launch. They used ISRO to launch basically demo and PSLV to do the early testing, GSLV to do the later testing, and all the demo is sorted. Meaning, can your phone communicate with the satellite? Yes, done, go home. Can your phone actually sustain a video call on this network? Yes, done, go home. So all those things are sorted. So target is by 2026 end, they should have 5 satellites in the market. Hopefully it's working, and it should start to give partial coverage as early as that. Once that happens, because be mindful, they do not need hundreds of satellites because of the super wide spectrum coverage and like the angle of view coverage. And again, it's higher than basically what Starlink is. And again, I'm pretty sure that's why they need that kind of power. Otherwise, the inverse square law will destroy them. So they do have very high oomph to cover such a large area. They should be able to start giving worldwide coverage where emergency services should be able to ping you without any issue very soon, assuming the 6 launches actually happen. So, and be mindful who they are launching now on SpaceX. So that's a very interesting proposition from an economics point of view. They are not fighting with VI, or they're not fighting with all the terrestrial systems. Like, bro, use our network. Like, either option A, buy SpaceX, you will get better input and output, as in like upload and download, but you have to buy a adapter, modify your truck. The end. Go home. And be mindful that 5 Mbps up or 3 Mbps up and 35 down may look very unappetizing, but in a remote location, that is short of take money. And that's Mark 1. That's Mark 1 technology. I am damn sure if this company works out, it will make Mark 2, Mark 3, and I can easily see that instead of using radio to bounce back, they will use laser to bounce back. They're like, okay, we absorb a radio, we transmit to mobile phone using radio, that gives us the penetration, but for mobile tower, we use laser. And one satellite should have at least 3 or 4 laser points so they can make sure the weather does not affect it. So there are a lot of potential, and again, they're getting some serious money, including US Army, including Saudi Arabia. The idea is either you send your soldiers with a communication portal, which again you have to do that with SpaceX, or their mobile phone, the end. So this is very serious, and again, they're gaining money, like there is no like $1 billion kind of money and a lot of interest. So we should look out for these. And now we come to Jeff Bezos. So Jeff Bezos, I do not know whether you know this, he has some amount of money. So he was like, hey, I do not like poor people, so I'm gonna make new venture. Basically, his poor people is Qplear or Leo or something like that. Is like, okay, that's for poor people. Let's talk for rich people. Enterprise grade customer. Translation: people with very deep pocket. People with so deep of a pocket they do not look at the expenditure. I'm not joking. I had the luxury of talking with people like that. It's weird. They do not know the cost of things because it's like, bro, it's like too few zeros for me to bother. I'm like, damn. So that's the idea. Directly targeting enterprise grade customer. Why? One enterprise grade customer will be equivalent to million of customers, and it's much stable income flow. So that's what they're targeting. And what is their USP? USP is they're not targeting a radio frequency. It will be way too costly, too much interference and all that stuff. They are directly using laser. So we already have Starlink, already have laser to laser, as in space to space. Done. Cool. Awesome. They're like space to ground. I'm like, why? Well, space to ground on the same wattage. Let's assume your satellite had 1 kilowatt of power for communication. In 1 kilowatt of radio wave, you will get, give or take, 144 gigabit per second. Not bad. But again, if you give that to data center is like, is this my third backup line? So optical, same amount of electricity, 6 terabits per second. Now we are talking. At 6 terabits per second, now we are talking. Like, who is talking? Amazon Web Services is talking. So that's their whole idea. And to achieve this, they are gonna have primarily on MEO. They are not focusing on LEO because again, they do not need that many radio. They're focusing on MEO. They're a bit higher up in the altitude, and that will provide the backbone. And this also gives them coverage for future brain damage of data center in space. I'm like, we humans tried putting data center in the sea. That did not work. It will not work in space. It's like, it will not. But again, if you're dumb enough to buy it, I'm smart enough to sell it. So Jeff Bezos is like, so that's the whole point. The medium Earth orbit, if you have anything in low Earth orbit, proper communication, laser to laser, laser to ground communication, same electrical consumption, but you'll have GG amount of throughput. And again, what if weather blocks your laser? Cool, you have radio to fall back. So it is not completely hopeless. So that's a logical approach. And the target, this is where it's different. They're not targeting on a lot of people. For example, this is their LEO constellation, which they are working on. Target, max customer serviced, many millions. Like, it should be expected for them to design the system to handle 1 billion customer. They should design for that. Be mindful, China has 1 billion plus people, India has 1 billion plus people, America, combine all these three, you are looking at 3 billion people. So if they're looking at good enough market coverage, they should design the algorithms and everything to handle billion. But on this Terawave, they're targeting only 100K customers. And even 100K is a lot. Like, there are not that many mega rich people where it's like, like you have Amazon Web Services, you have Azure, you have OpenAI, you have NVIDIA. There are not that many. Like, by the time I go through like top 50, 60, the money starts to dry up. So I can easily see that, like multiple sites. But, and again, AI boom will happen, bust will happen, and then what? So that 100,000 is too much. But again, even one of those customers will print money, and they are their own customer. Amazon Web Services is huge. So they are on there. Although all this being said, they have deep pocket, they have rocket, they have the technology. The weak link is rocket launch. Meaning, while they did launch a rocket, and it's an amazing thing that they launched it 2 times, it deployed payload in orbit both times, and second was a paid mission and freaking deployed Mars mission. amazing. It's just that their cadence is not good enough. Meaning, at this point in time, when you're watching this video, they should be close to their third mission, which should be deploying stuff on moon. And again, if it lands on the moon on first try, damn, they got some good engineer, some like well compensated engineer, like shut up, take money kind of engineer. Like, just come here, bro. Don't ask for money. Like, put your hand on things. We'll afford it for you. Just like if they land on the moon on the third try. So, but again, all that being said, their cadence sucks. We are looking at best 6 launches in 2026. That is not enough for this sort of thing. Yes, it requires much less satellite compared to Starlink or even to their own system. It's still not that low. They do need to increase the rocket cadence, almost like 52 launches a year. So they're not there yet. That's their weakest link. So, and SpaceX, after realizing that, and again, because they are targeting rich people, SpaceX is like, yo, rich people, I need rich people too. So they're like, we can also do the same thing, although not with current system. They have the infrastructure. Satellite to satellite laser is that powerful. It's just that it was not designed to beam back. So in V3, they can optimize it, or they might already have it, that laser to ground. That will require a different wiggle-proof laser system, but it can be done. It's not impossible. But again, there is a very good chance they will require Starship to be working and completely new system to make sure that's ready for mass deployment. But it can be done. And again, this is the interesting part. Like when Starlink was announced, yeah, like there is no competition. Now we are looking at two competition. Both of them have genuine chance of doing something. Not guaranteed kaput to them, but genuinely something. And you always want multiple options. That's always good. And again, US Army knows that. That's why they are spending so much money in all of these things. It's like, we want options. It's always wise to have options. So that is Terawave for rich people. Now, all that is hype, good and all that, but we are reaching some dangerous point, like serious Kessler Syndrome kind of point. Earth has only one sphere, and it is a shared ratios, meaning Chinese people use the same sphere as Indians do. Indian use the same as Pakistanis. Pakistani use the same as Americans. American uses the same as Saudi Arabians, and Saudi Arabian is the same as Iran. So we all are sharing the celestial sphere, so to say. And if number keeps growing exponentially, be mindful, before SpaceX, if you had said 10,000 satellite, people are like, bro, pass the joint. Now we have crossed that. Like, I know for a fact that we have crossed that. Like, that's scary. And be mindful, that's just one constellation, and there are people who are going YOLO. It's like, we're gonna launch 10,000, we're gonna launch 20,000, we're gonna launch 35,000. And be mindful, these are people with deep pockets and enough horsepower to actually try to do it. That's scary. Meaning, we have reached a point mathematically that one oops event, one mistake, one command failure, one electronics failure, or again, you're like, okay, we are awesome, we are humans, we are gods, we never make mistake. Let's assume that one bad weather event, aka solar weather, meaning if sun sneezed too hard, yeah, it will all doom us all. Like flat out, it will shift, delete the celestial sphere completely. Like if we have 10,000, like 20,000 current target, like I'm pretty sure if you look into numbers, what everybody is claiming that they want, it could easily cross to 50,000 satellites. If you have that many, and be mindful, Kessler Syndrome will not be limited to low Earth orbit. If it happens in low Earth orbit, it can easily spread to very far, like MEO would be shredded. And once you lose LEO, you can't launch rockets. So even if, let's just say, geostationary satellites survive, hope they last forever, because you won't be able to launch it. And at that point in time, decay will not happen very quickly. So that's the dangerous part. And again, at 1,000 satellite, it's not really an issue. At 10,000 satellite, it is an issue. At 100,000 satellite, which everybody is trying to hit, it's inevitable. Like, the too many variables are there. Like, too many satellite constellation has to work perfectly all the time, 100% time. It's uncomfortable. Like, it's almost like people's illusion with nuclear. It's like, we're gonna make nuclear, nothing bad's gonna happen. 3 Mile Island happen. We're gonna make nuclear, nothing bad is gonna happen. And the Chernobyl goes boom. We're gonna make nuclear, nothing bad ever gonna happen. Then Fukushima happens. It's like, humans make mistake. Like, human problem. Okay, I'm not talking about science or engineering. Humans make mistake. And adding space weather to it, unwise. Be mindful, this is 2024 NASA readout. It like literally plunged the magnetic waves, like it literally reached the midway to USA. That's brutal. That was in 2024. If we had, and be mindful, it did fry satellites. It's like it cooked satellites orbits, because again, it expanded the atmosphere so much. Many satellites said, whoa, why I'm experiencing drag? I'm not a fighter jet. It happened. It's a real thing. Now, again, it was a minor bit slap. Sun is teaching us, bro, pay attention to me, pay respect to me. So, but again, you can understand that if you have 10,000 satellites, it's a bad deal. If you have 100,000, it's a guaranteed a boom event. So that's the whole thing. And here's the Kessler Syndrome is very, what you call, unbiased. It does not care who launched it. It's very fair. It will shift delete everything. Meaning it does not matter whether some Iranian is like, okay, death to America, death to Israel, and actually does Kessler Syndrome, triggered the Kessler Syndrome, nothing will matter. It's like shift delete the whole system. And there won't be any safe orbit. Flat out, you will not be able to launch because most of the garbage is in low Earth orbit and it will not decay if all of them get shredded into smaller parts. So that's a very serious problem. And be mindful, we don't even have a theoretical model how to clean it. Like all Kessler Syndrome is like, oh, we can launch satellite, we can go and grab it. It's like, what if you can't launch? Like there is no theoretical concept. The only thing that I can even remotely think of, use all the ancient ICBMs. They were designed to be battle hardened. Hopefully they have strong enough shell to handle it and go there and have a water tank and detonate nuke in the water tank. So it creates enough steam pressure to like create a corridor of space and then you send another one. So that's the only thing I can even theoretically think of as like, how can you cleanse the orbit? So we don't have any idea. It's like, if this will happen, like we have contingency plan. What happens if a dam goes kaput? We have plans for it. What happens if a nuclear reactor goes kaboom? We have plans for that. What happens if Kessler Syndrome happens? No plans, nothing, no idea. And again, nobody wants to because it's a shared resource. So this is a very, very serious vulnerability. Again, it was not an issue when thousands of satellites were in concert. It's a big ass issue when we are talking about 10,000, 20,000. 50,000, 100,000. It's no longer, it could happen, it's like, it will happen. Just make sure we reduce the satellite number before we need that. And here's the tragic part. Do we really need that? Because again, that's why I talked about ATS in this so much. It's like, if they are doing it cleverly, 200 satellite would be like, bro, we have surplus. GPS, GLONASS, all of them, TV communication. And again, why does America need Starlink? Because of corruption, not because Starlink was needed, simply because America had brain. America, back in the days, like 1990s, they were like, hey, if we had internet in places, people are start to grow, businesses start to grow. It's like, let's expand business. Companies were like, okay, we can't go there because the fiber line to there, like let's just say central area, fiber line to this village will cost so much that it will take 100 years to pay it off. Government is like, cool, we got you. We collect taxes for this. We're gonna give, subsidize it, basically pay you money, almost like what, $1 million a year or something like that. You can correct me on that. And we're gonna pay you this much. You're gonna lay the fiber line, and brick by brick, year by year, you're gonna slowly expand your fiber network. We're gonna take care of the capital cost, and you're gonna have customers. Everybody wins. Our constituents gets internet, GDP grows, more taxation, we become richer. You get like, you know, the initial edge. They did that. Millions of dollars annually, and all the telecom company did. There was no scenario that America should have needed Starlink, not for people. Like it should have been like, okay, forestry service. But again, if you are only focusing on them, you do not need 50,000 satellites. You don't need that. So again, I get that, like, you know, planes. What if I want to give internet on planes? You can do that from ground. And again, you can do that with satellite, but you don't need that many satellites. There are not that many planes active in any airspace. Not that many. Like not millions of planes in space. In airspace. Yeah, we don't have that. So fundamentally, this whole approach is like, do we really need that? Like, again, I really want satellite internet to be a thing in India, but not as a main thing, as a backup. Like, you know, hey, something happens, natural disaster, those things make sense. But as a main backhaul where we are like putting 20, 50,000 satellites, yeah, that's not needed. That's like dangerously not needed, because be mindful, we are also away from one madman syndrome. If one madman decides, like let's say Putin decides, oh, I'm gonna go down, I'm gonna take down the whole civilization. Be mindful, we have done this. We, humanity, went through a retarded stage where two nations, USA and Soviet Union, USA was like, we're gonna build 10,000 nukes so we can kaput the whole planet. Soviet Union is not so fast, we're gonna build 40,000 so we can kaput the whole planet. And everybody else is like, the hell? Like these two retards are going boom, boom, boom with each other and the whole planet dies. We are at the same stage again. That's why, like, do we really need this sort of stupid number? Like the numbers are too huge. It's like, oh, we can give internet to cruise services. How many people are in the cruise, man? Like, really, like, again, at some point we have to do a calculative math. Like, thankfully we learned from Cold War and we're like, hey, let's chill, you know, let's chill down. I really hope this, like, because again, the numbers are too stupid. It's like, China is like, we're gonna launch for 35,000. Kepler is like, we're gonna launch 35,000. We're gonna launch 12,000. We're gonna launch. It's like, what the hell? We have only one shared sphere. One oops event kaput everything. Oh, and remember, it did happen. China did had a scenario where one space debris did punch a hole in their mirror, and they're like, we have to delay the landing mission. That's a human mission that got oopsed because of a debris. How big of a oops event can happen before ISS is like, yeah, abandon ISS now. So let's be very clear. This is becoming a bit too serious before people are really ready, or at least on paper come up with the idea. It's like, if Kessler Syndrome does happen, what are we gonna do to clean it? So this is scary. So this was my presentation on basically mega constellation of 2026 and the dreams and horrors of it. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.